So, good morning, friends. I welcome you in this very important session of your course. And today, I will deliver a very important and new techniques of fast reaction. That is, story of ultrafast techniques and femtochemistry. Deliberately, I have chosen this title because only last year we have introduced this new course content, because you all are aware of different fast reaction technique. Say for example, day before yesterday I discussed about the temperature jump method, pressure jump method, as well as the flash photolysis. That is also sometimes, the time scale is very important. Means the half-life period, like that 10 to the power minus 2, 10 to the power minus 3, or 10 to the power minus 7, 10 to the power minus 9, and that range is also comes under the ultra-fast technique. But there are many reactions, particularly some biological reactions, some reactions in the material science, photodissociations. There, that transient species half-life is very, very small, like 10 to the power minus 12 second to 10 to the power minus 15 second. So therefore, such type of reactions cannot be studied by this simple spectroscopic technique. Therefore, a new technique have been emerged, and that is called the ultrafast technique. And of course, frankly speaking, that this is a very, very big topic, and it is a research oriented topic. So what I am decided that I will deliver 2 lectures, or I will give 2 or 3 lectures. But today I will concentrate only on the fundamental aspects of that ultrafast techniques. I will not discuss the physics of this pump probe spectroscopy, or I will not discuss details in the transient absorption spectroscopy. It is a very, very big chapter, but I will, therefore I have just, you can call it the genesis of that, what is actually ultrafast technique, how do you explain in the examination, suppose it is a femtochemistry or like that. So that is my intention. And if you have faced any problem, feel free to interrupt me during this lecture, because it is again and again I am saying, it is a very interesting subject, but it is a research oriented topic. Now, before I start the main objective of this course content, I will tell you the whole time scale, or the time scale for different types of the reactions. We can start from stop flow technique. If the half-life period is 10 to the power minus 3, we can study using the stop flow. Then gradually, if it is temperature jump method or pressure jump method, we can study up to 10 to the power minus 6. But as I told you just a few minutes ago, that if these, because the concept is exactly same, that means A plus B, suppose I am talking about the AB plus C reactions, and there is a transition state, same thing. I'll explain gradually. excited state, and or suppose it is a activated complex, then maybe AC plus B or whatever it is. But suppose the transition state half-life is like 10 to the power 15, then of course we have to use the femtochemistry. And why I have written 1999? That is very, very important, because a great scientist, and today's presentation is based on his work. I must salute this great scientist, late Professor Ahmed Zewail. Actually, he was awarded Nobel Prize for the development of this femtochemistry. And therefore, I have just written this 1999. But he actually started his work from 1980 to 1987. He discovered this femtochemistry, and there are a large number of research papers. I will show you. And you will be again happy to know that that is not the end point, because it is related to the motion of the atoms and molecules. But if you want to study the motion of the electrons, that is also a very important concept. But again, 2023, three scientists was awarded Nobel Prize for that 10 to the power 18, minus 18. And that is, of course, Nobel Prize in physics. And that I will not discuss the attosecond spectroscopy and other things. That is also the latest development. Now, I have already told you that most of the biological reactions or atomic motions, different types of scattering reaction can be studied with this femtosecond spectroscopy. And it is basically, as you know, that the scale, if you see, of course, here 10 to the power minus 13 like that, this scale up to picosecond to nanosecond, picosecond to femtosecond comes under this ultrafast technique. And 10 to the power minus 3 to 10 to the power minus nanosecond is also flash photolysis part is also there. But this part is actually we are concerned about this 10 to the power minus 12 to 10 to the power minus 15. That is actually basically ultra fast technique, and that spectroscopy is called the transient absorption spectroscopy as well as the transient time resolved spectroscopy. I will come to that point. So it is actually 10 to the power minus, it is not well, minus second. And in order to understand the molecular reaction dynamics, so we have to apply this femtosecond spectroscopy. You can call it the femtochemistry, because traditional methods cannot capture such type of things. Now you just imagine that, yes, same thing, bond breaking and bond making. But during the transition period, suppose you are able to snap all those, sometimes it is called the snapshots like that. So that science is developed. That means Ahmed and his group, they are able to monitor that each and every species by that femtosecond spectroscopy. Just they are able to take the photographs, sometimes we call a snapshot type of the photographs. And as you know that I will dedicate the whole lecture to this great scientist, and his name is Professor Ahmed Zewail. And I will request all my students that there are large number of excellent, simple research papers written by this great scientist, and most of this material, most of these photographs, graphs, instruments I have taken from his research papers, and he is the pioneer in this field. Actually, he actually developed this femtochemistry, and there are a large number of research papers, and you know that it is called is ultra-fast reaction dynamics. But unfortunately, he passed away in 2016. He is. So therefore, after his death, there are a large number of research papers. And if you read his research papers, as I always discuss with you, I always start with any chemical kinetics from that great Arrhenius equation, then Eyring, and then Polanyi, then Lee, because this is a technological development. And if you read these very excellent research papers, a century of chemical dynamics, because he started from 1901, first Nobel laureate in chemistry, one top. Okay. So, and then he was awarded Nobel Prize in 1999, like 100 years of chemistry. So, therefore, he has given all the information that Arrhenius contribution, then transition state theory is also there, and then ultimately you all know that transition state spectroscopy I always consider. So, therefore, I just deliberately, it is a story of ultrafast technique. I will not go into very details of physics or chemistry of that pump probe spectroscopy. But in my next class, I will of course go the details of that spectroscopy. But today it is a history, it is a story. But you can understand that a very simple language I will try to explain that what is actually pump and probe method, a very simple way. And suppose you want to read some Indian research papers, okay. So, in our country also there are some great scientists like Professor Kankan Bhattacharya of Indian Association for Cultivation of Science. He visited our places, delivered the lectures on ultrafast technique. Then Professor Pushpendu Kumar Das, ISC Bangalore, they have also written many research papers based on, because they are also working on the solvation dynamics or ultrafast technique in our country. So, if you want to learn more about this femtochemistry or ultrafast technique, you can refer this very simple research paper published in Resonance after the discovery of this Nobel Prize in this, so in 2000. So the man behind the femtochemistry, and very simple language it is written, and I have also taken some of the graph, some of the diagram from Professor P.K. Das research paper. Similarly, I mentioned another scientist, also he is no more, Professor Kankan Bhattacharya. I know him very personally, he is a well-known physical chemist, and he also written a very good research paper, again in Resonance, before the announcement of the Nobel Prize. You see, it is published in June 2000, of course, not after the death of this Ahmed Zewail, and the title of, you see, the king of femto land. You just, and there is a one very important paper written by Ahmed Zewail, the born of molecule, born of एक मॉलिक्यूल की जन्म, मतलब रिएक्टेंट से प्रोडक्ट बन रहा है, बीच में ट्रांजिशन स्टेट है, उस ट्रांजिशन स्टेट को कैप्चर कर लेना, दैट इज देयरफॉर ही गिवन द टाइटल द born of molecule. Okay, so I have also taken some of the diagram from this great scientist Kankan Bhattacharya. At that time he was at IISER Bhopal. So he has written also this very good story of this Ahmed Zewail and other things. So you can also refer to these books. Now, because we are doing the ultrafast technique, so of course this is not in your course, but you must know that what happened after this femtosecond regarding the electron dynamics and other things. So it is called the attosecond spectroscopy, and there are three scientists, Pierre Agostini, Professor Krauss, and Wheeler. They also awarded, because you can monitor the atom, you can monitor the other structure, but it is really very difficult, extremely difficult to monitor the electrons movement. But ultimately, that is also possible. So therefore, this technology is very important for chemistry. Chemistry is everywhere. And of course, you know that material science is also chemistry. And of course, medicine, drug designing, and everywhere people are using the femtochemistry. And now I'm coming to the subject, actually what is actually femtochemistry. And there is a term that is called pump and probe spectroscopy. And there are many type of spectroscopies are involved. But as I told you that today I will discuss only the fundamental point first. If you see the recent paper 2024 and 2023, because there are different types of femtochemistry, even Raman femtochemistry, Raman and other things. So, and you see I am very old paper, 25 years old paper. So it is not, for you it is new, because we have introduced in our course content, but for scientific community is not new. I am using 25 years old research paper published in femtochemistry. Past is Arnias, Eyring, Polanyi, Lee, future is attosecond. So he has already given all these things, and basically during the transition state theory we use the partition function and we monitor the vibrational motion and translational motion, but beyond that, that is very important. And also you saw that there are many books available, but this is one of the very famous book, very popular book written by the Ahmed Zewail, Femtochemistry, Ultrafast Dynamics of the Chemical Bond. And all the papers are very, very interesting, very, very important. And there are many review articles based on this ultrafast process. And you know that chemical reviews is one of the most important journals published by the American Chemical Society, and the impact factor is very high, more than 60 or like that. So, and the language is also very simple. You can see that in the first sentence, if I read, ultrafast science has a truly interdisciplinary and strong impact on modern physics, chemistry and biology, elementary electronic, atomic and molecular motion. That's all. We can monitor the electronic, atomic and molecular motion. So in order to capture all those motion, we need such type of pulse, or like that, short-lived pulse, that can monitor that things. So we need laser. We need some laser. So that is the theory behind these things. And you know that there are so many ultrafast spectroscopy, state-of-art and open challenges, femto to attosecond durations. Because why I am giving all this information to you? Because when I have searched all the books like Atkins or G.M. Barrow, I will not find any topic, any chapter related to that femtochemistry. Only very elementary part is given in the book of physical chemistry by Alberti, Daniels and Bawendy. They have spent only 2 to 3 pages regarding the femtochemistry. So if you want to refer some textbook, please refer the book of Alberti and Daniels. There is one small part regarding the transition state spectroscopy and other things. And as I told you that after the death of a great scientist, this was a tremendous loss to the community of the scientists working on the ultrafast phenomena. And he actually allowed to atomic motion to observe the real time, at the atomic scale time. And there are so many preface to special topic of this. So I have taken some of the graphs, information from, I must confess. And again, you know, whenever I discuss any Nobel laureate work, I always mention the lectures given by that scientist, like Marcus I have already discussed with the RRKM theory, like that. And when he delivered a lectures in the history of Nobel Prize, and he title is Atomic Scale Dynamics of the Chemical Bond using Ultrafast Laser and other things. So one thing is confirmed that we need some laser, and we have to excite that molecule and then we have to interrogate of that different transient species, and then we must have a detector and we monitor the thing. That is the things. So I have also taken these things, and basically he was a Egyptian, but he was working in a very, very prestigious university. You all know that, Caltech, California Institute of Technology. So the great institute. And of course, he never forgot the whole system of Bodenstein. You know that chain reaction, hydrogen and iodine type of the chain reactions, and the fundamental work of Arrhenius and other things. You will see all these things. So there are so many, why I am showing all those things, that he always used all those old study and other things, Bodenstein concept and other things. And when I will teach after the completion of that fast reaction, in your course there is a barrierless chemical reactions and probing of the transition state. So I must mention the name of that scientist, and I think I have already mentioned, because Bakchi's theory in your course, barrierless chemical reaction, Professor Biman Bakchi. Again, he is from Indian Institute of Science, Bangalore. Again, he also visited this place, delivered a lecture during our CRSI conference, and he also discussed so many things about this, how fast is ultra-fast chemistry, because that is very important. The field of ultra-fast chemistry has seen a string remarkable discovery in the recent years. In this article, he briefly discussed the different types of the biological work and other things. Anyway, now I will come to my topic. Now you see, when he was young, and I think there is a journal, the name of that journal is Chemistry and Engineering News, published by again American Chemical Society, and most of the time they publish some new research, new things. So when he was working with another scientist, Richard, of course he is University of California, and you see he's a young man, and that time, as I told you, that he discovered that phenomena in 1987. In 1987, of course, Nobel Prize was awarded in 1999, 199, but he discovered. And during 88, 87, he discussed with T.S. Lee and Herzberg and other things. And first time, actually, he given this laser femtochemistry and viewing the transitions from the reagents to product, first time. And he was excited. And he has given so many examples, like reaction with sodium iodide, Na, CS3I. I'll show you his some of the example. And so this is one of the paper, and deliberately I have given this. And it is published in Chemical and Engineering News, C and EN, 1988, November. I think page 24 to like 40. So, no, just why I am just showing these things, why it is I am important, because you see, the century old, whenever I teach any chemical kinetics, even in the B.Sc. B.Ed student, I always refer this great thing, that is Arrhenius equation. You see, that is the starting point. And relaxation technique, hygiene is also important in other things. So when he discussed these things, he also mentioned the contribution of that Arrhenius, and then relaxation technique. You see, the point I have already, I think day before yesterday, I discussed the relaxation kinetic. We just part up the equilibrium. That is also part of that ultra-fast technique, relaxation technique, temperature jump and pressure jump. But again, there was some problem that we need to measure the range 10 to the power minus 12 to 10 to the power minus 15 type of time scale. That was a problem for them. Then of course you also know about the cross molecular beam experiment regarding the molecular reaction dynamics, infrared chemoluminescence method. They have also tried to catch that transition state. So these are all the further development. Polanyi, Lee, and there is also Nobel laureate 1986. But ultimately, these methods are not suitable. I am not saying these methods are not good, not suitable to study this type of things. So therefore, the time scale that time up to Polanyi or T.S. Lee, that is molecular vibrations and other things. But if the reactions are very, very fast, so real time observation of molecular transformation is very, very important. Why it is called real time? Because if you consider those motions and that transient species, short-lived species, their half-life is 10 to the power minus 12 to minus 15. So it is a really, this transformation is very, so it is a revolution to understand the molecular reaction dynamics. Whether it is a simple chemical transformation, slow reaction, or it is a very, very fast reaction, the objective of a chemist, we must know the what is happening in the molecular world. How fast is the reaction. So therefore, we need to develop femtochemistry, or sometimes it is called the transition state spectroscopy. Now, it is a very, if I ask a short question, that how do you, because it, as I told you, it is a very, very broad subject. After listening my lecture, you may visit to library, you may visit your smartphone and other things, and you just try to search what is the classification of ultrafast spectroscopy, or what, how do you explain the pump probe spectroscopy. So it is very difficult. And you are in M.Sc second semester, M.Sc first year student, and you don't have any strong mathematical backgrounds and other things. And if I ask you what is the difference between the transient absorption spectroscopy and time resolved spectroscopy, it will be difficult for you to monitor the things. But fortunately, we have recently purchased a very sophisticated fluorescence spectrophotometer. We have already seen that time resolved spectroscopy fluorescence can, most of the research scholars, most of the M.Sc students are now using the fluorescence and other things. And you know the Jablonski diagram, what is absorption, what is fluorescence, singlet transfer, triplet transfer, triplet transfer, you all know all these things. But for the clarity and novelty, I am not also expert in this field. I have collected all the information from different literature, and particularly based on Ahmed Zewail. So I have seen that the starting point of this pump probe spectroscopy, starting point is the transient absorption spectroscopy, or it is called the pump probe technique. First point, pump probe technique. Now, when I was teaching, I think day before yesterday, regarding the relaxation technique, I told you that if you see the normal spectroscopic technique, so you know that there is a S0, S1, like that, S2, then triplet state, like that. You know these things. So, if I am talking about the pump and probe, very simple thing. And that day I told you, you all know about the simple absorption of ground state. Okay. But that day I told you there is a absorption in the excited state. I told you, no, I told you that a big, due to shortage of time, I am unable to draw that. That is called this is general absorption from ground state to excited state. But suppose the color is slightly different. So in order for that excitement, for initiation, in order for that, just like UV visible spectrophotometer, you apply, the whole classification is based on the types of the, again and again the same thing, interaction of the matter with the electromagnetic radiations. So classification is also based on these things. So therefore we need some light source. So suppose that light source is called the pump, P-U-M-P. Same thing here is also possible. I am not talking about the fluorescence. Fluorescence is also possible. Another problem is that the second transition, that means the absorption in the excited state, another laser that is called the probe. You can use one source, I will show you the picture, and use a beam splitter. So first you pump laser, which is short-lived, and second called the delayed, that is called the probe, and that is responsible for that. And then of course there is a triplet to triplet transition is also possible. Now in the language of when I have referred all those things, मैंने देखा कि there is a very beautiful dialogue that is called the interrogation, like CBI or ED raid. That means once you apply this laser and it is excited state, and there may be some optical changes and other things, then you send the CBI or you send the ED through the probe, and they will interrogate the different type of processes and then radiate and other things. So therefore it is called the pump probe spectroscopy, and it is up to you whether you are monitoring the absorption, transmittance and reflectance, or you monitor the fluorescence activities and other things. So therefore on the basis of this thing, and then that CBI or that probe interrogates these things, and the light range is 10 to the power minus 50, so they are able to create the photographs. So therefore it is called the molecular movie. So therefore it is called that is the basis of that pump probe spectroscopy. And of course depending upon it is transient absorption spectroscopy, you can call it. You can call it time resolved fluorescence spectroscopy. Maybe there is a difference between the transient absorption. So maybe here this to this, this to this, this to, there are so many processes and other. I will not go into the details of the physics of other things. Then nowadays people are using terahertz pump probe spectroscopy. These are all technique. Then X-ray pump probe spectroscopy, capture atomic level structure. Quantum effect is also very important, wave packets and other things. But always bear in mind that we are not studying the complete femtochemistry or femtosecond spectroscopy or pulp. What is our objective? We are doing the studies of fast reactions. And there are many methods: top flow, shock tubes, relaxation, flash photolysis, NMR, and one of the method is ultrafast technique and the femtosecond spectroscopy. Therefore, we are confined only the fundamentals of. If you will read complete of pump probe techniques, then you must have a knowledge about this pump probe spectroscopy, and there are so many derivation and other things. But आपको केवल फास्ट रिएक्शन में बहुत सारे टेक्निक के अंदर वन टेक्निक इज अल्ट्रा फास्ट टेक्निक. सो इतना नॉलेज आपको होना चाहिए. यू मस्ट हैव नॉलेज अबाउट व्हाट इज एक्चुअली पम्प प्रोब टेक्नोस्कोपी, इसमें कैसे कैलकुलेट किया जा सकता है, एंड यू मस्ट गिव वन और टू एग्जाम्पल. ओके, यू फॉलो माई पॉइंट. थोड़ा इनको घुमा दीजिए. Do I make my point clear? What is actually femtochemistry, and that laser pulse must be in the range of 10 to the power minus 15. So we need one pump, we need one probe. एक भी हो सकता है, एक सोर्स भी हो सकता है, बीम स्प्लिटर से हम उसको अलग कर सकते हैं. लीनियर भी हो सकता है, नॉन लीनियर में भी. अभी मैं 2-3 ग्राफ दिखाऊंगा. अब देखिए. Now, pump of spectroscopy, first is that, now it is clear that there are two things. One is laser pulse. You all know that light amplification. It is always stimulated emission, not spontaneous absorption, stimulated emission. That excite the sample. I have already discussed these things. Now you can, because it is up to you that how you interrupt, how you interrogate that action. So by monitoring the probe, you can monitor these things. And the difference between this, suppose I am using this is pump and this is probe, another color. So the time delay, this difference between tau, we can monitor this thing. So first laser pulse we apply, then delayed second pulse, different time intervals. By varying the time delay, one can track reaction dynamics in the real time. You can take the pictures of like that. Now I am giving some photographs. You can understand these things. I am taking these photographs from a research paper that is from MIT. You all know that is one of the most important big university in the United States. And there are different types of pictures like that. So first, the high intensity pump laser excites a significant percentage of the molecules to a higher energy level, altering the population difference. And next, a low intensity probe laser is passed through the sample to measure the absorptions. Based on the difference between the probe and pulse, this difference, tau value or T you can call it. So this process is then systematically repeated for different delay times between the pump, because once it excited and then from excited level to another level, then we monitor this type of transient species with respect to time, picosecond, we can monitor these things. So that is the basic. I'll show you some of the examples. This picture is prepared by Abhishek Katendra. Such type of picture is also available in most of the research paper. So there is probe, sample. So you see that sometimes linear, non-linear types of the things, and this difference between these two probe, one is pump and probe. In the last part of my lecture, I will discuss what type of laser we can use. You can ask me, sir, what type of laser you will use and how that beam is splitted and other things. I will show you the actual diagram. There are some instruments are also available nowadays. I will show you some of the instruments which Ahmed Zewail used in the Caltech. आपको तो यहाँ पे एक सिंपल दिख रहा है, दो लाल कलर पंप दिखा दिया, प्रोब दिखा दिया, सैंपल दिखा दिया. It is not like so easy. It is not like, it is a fundamental things that how it is absorption, then absorption in the excited state, absorption in the excited state, and then there are different tangent speeds. अभी मैं photographs दिखाऊंगा आपको. And everywhere the same thing is also there like that. इस तरह से आपका होगा. Same, this spectroscopy is exactly same thing. That there are so many points, and then fluorescence is also there. There are so many things are there. मैं बहुत ही सिंपल लैंग्वेज में आपको बताने की. Now again I am taking this technique from a very good research paper. An introduction, because you see that I am using very simple diagram. Of course, I have taken all the diagrams from the internet, from various research papers, and I mentioned their name. You see, if you see the first diagram, prepared by Abhishek Katendra. No, sorry. Same thing, everywhere you will see large number of different types of diagram. But suppose I am using one laser and one beam splitter. You see here. This is laser. Maybe here is some beam splitter. And always I use that pump first, not laser. And path may be different. And then of course, there may be different mirror. I will show you different types of the mirror. So the laser is split to pump and probe beam. Same thing. And a pump probe spectroscopy is a tool to study dynamical process. The physical system must be perturbed. Why there is a relationship between relaxation technique and flash photolysis. But flash photolysis range is -3 to -9, maybe 3 like that. So beyond this. So then again the sample you see, then detector must be there and other thing. Now I am showing one diagram of Professor P.K. Das, researcher from the resonance. Now you can understand the simple thing. Again you see that there are different types of mirror and there are beam splitter, but you see the difference between the time delay between this probe and pump. This tau value you can write like that. Then molecular jet and other things. Same, capture photographs in the reaction in that particular instant, like the, and then there must be some signal and other things by that method. Schematic diagram of the femtosecond apparatus used by Zewail and his course in Caltech. As I told you, I must confess that there are different types of pump, probe, spectroscopy, but today's lecture I am using only the fundamental concept developed by Zewail, and it is 25 years old. But first time you are referring this thing, तो आपको लग रहा होगा कि मैं कोई नया चीज़ पढ़ रहा हूँ. अभी अगर देखेंगे तो बहुत एडवांस लेवल, इफ यू सी द रिसर्च पेपर ऑफ 2024 एंड 2025, तो आप केवल गूगल में यू सर्च दैट पम्प आप देखिए. लेकिन यू आर स्टूडेंट, एग्जामिनेशन इज ऑल्सो इम्पॉर्टेंट. फिर आपके कोर्स के अंदर में ये है फर्स्ट रिएक्शन, देयर आर वन टेक्निक. सो मैं 2 पीरियड इसमें यूज़ करूँगा कि सो दैट कि you can understand these things. Now, as I told you, because I use this language from interrogation. I like that sentence, very good. Excite electrons, no problem. Then probe pulse, interrogation. Because that the duty of pump is only just exciting up to S0 to S1 level, that's all. In between there are intersystem crossing, singlet to triplet, maybe triplet to triplet, T1 to T2, everything is there. But second laser follows this, he will do that interrogation. And that CBI or that part measure the changes in the molecules of the optical property, maybe absorption or the emission. If it is emission, then we will call it time resolved transient spectroscopy. It is absorption, we measure. So we will. But what is the difference between normal and system? That time, that Ahmed Zewail used femtosecond laser type of the things. So therefore it is called the femtochemistry. But pump and probe is simple thing. And by repeating the process with different time delays, researchers can reconstruct the series of image showing the atomic movement. अभी आप जब मैं आपको when I will show you some diagram, you can understand what is happening. Again and again, same thing, A plus B, C. So you all aware of the transition state. But if I ask you, can you detect the transition state? In 1930 you may call, no, sir, not possible. But now it is possible because that is called the transition state spectroscopy, TSS. इसके बाद मैं शायद इसको पढ़ाऊँगा सेकेंड आपके कोर्स में, शायद हम लोगों ने डाले हैं. आई थिंक यू चेक योर कोर्स, ट्रांजिशन स्टेट स्पेक्ट्रोस्कोपी. So that is the same thing, but some modification and other things. So now I am showing some of the photographs. So now that why I have written so many big things, because now you understand pump, you understand excitement. Now you understand that there is the excitement in the absorption in the excited level. But how do I measure that signals? The signal from such experiment recorded as a function of delay between this pump and probe. That is the most important thing. That delay. You can monitor this thing. Is clearly dependent on the rate of molecular process involved, fortunately. So they monitor these things. Now, again you see this is the beautiful example of pump probe experiment, and it is the simple example of reaction between or the photo fragmentation of CH3I. A very simple example, and again I am taking from this in the 1988. Not that time he was not awarded Nobel Prize. He just published a paper, news, with that great scientist, Bernstein, Richard. So you see, now you can understand any M.Sc student or a student can redraw these things. Nothing difficult. So you see, it is the ground state, pump laser. So it is an excited state. Then again, this is probe laser. You see, it is, you can call it excited state. Then we use the probe laser. So then there is excitement again, and then this we can, that is called the photo fragmentation in the picosecond. That time 10 to the power minus 12. So concept of picosecond laser experiment determine the bond breaking time of methyl iodide is shown in symmetrical left. A pump laser excites the CH3 molecule from the ground state to high. Language is also very simple. Iodine produces detected. So again it is an interrogation, because there are two forms, CH3 and iodine. So who will detect these things? That probe, and that is very fast, 10 to the power. So normal produce the results of below. Then there is whatever the things and other things. And this I have yesterday also I have referred this PhD thesis of this student L.R. Hundkar, and it is available in the internet, guided by the Ahmed Zewail. I have just gone through this. Now you know that there is a flood of literature. आप जितना ढूंढना चाहेंगे, मेरे पास समय था तो I referred most of the research papers. मैं बहुत सारे जीरोक्स कराया. फिर मैं सोचा कि नहीं, थोड़ा आज आपको फंडामेंटल बताया जाए, बहुत गहराई में मैं नहीं जाऊँगा. So next class में जाऊँगा. So iodine as a signal. So they monitor this thing. Now again another example, and I am taking from this just second example. ये देखिए, photo fragmentation oriented confirm the prompt dissociations. Then snapshot, जैसे आजकल हम लोग कोई चीज़ का snapshot ले लेते हैं, फोटोग्राफ्स ले लेते हैं किसी चीज़. उस समय ये जब अभी स्नैपशॉट उस समय लोग जानते भी नहीं थे. स्क्रीनशॉट इमीडिएट आप लेते, घोड़ा दौड़ रहा है उसको ले लेते हैं. अभी कैमरा में, आई एम नॉट टॉकिंग अबाउट 2025, आई एम टॉकिंग अबाउट द 1988 and 87. That time also snapshots and how to create that photography is very, very difficult that time. So typical experiment, detection of the CH3 and excited things or other things. Iodine ion signal, that are the signals of that iodine ion. And you see the time scale is also there. And this is the actual photographs, part of Caltech femtosecond, including, now you can understand. मैंने आपको एक ग्राफ दिखा दिया, pump probe sample detector, that's all. But now you see the system, and so nicely he explained the idea, the pump part. आपको लग रहा होगा एक ही चीज़ मैं बार बार बोल रहा हूँ, because जितना भी मैं रिसर्च पेपर I referred, everywhere the language is very, very simple. So आप forget about the CH3I, you just A, B, C. The probe pulse delayed by a detects the photo fragment product say AB, and as it is being formed in the process of separation of C, the probe laser is first tuned to wavelength corresponding to the known excitant resonance, and then a typical curve and fragmentation process and everything is there. तो आप देख रहे होंगे कि the language is very simple और इसमें कोई बहुत ज़्यादा प्रॉब्लम नहीं है. यू कैन एग्जामिनेशन तक आप इतना लिख सकते हो कि व्हाट इज पम्प प्रोब स्पेक्ट्रोस्कोपी. एंड अगेन आई एम टेकिंग अनदर एग्जाम्पल फ्रॉम पीके दास. आई एम जस्ट गिविंग वन और टू एग्जाम्पल सो दैट यू नो दैट वी मस्ट हैव सम वन और टू एग्जाम्पल. सो अभी तक आपने फ्रैगमेंटेशन देख रहे थे. नाउ आई एम टेकिंग द बॉन्ड ब्रेकिंग एंड बॉन्ड मेकिंग प्रोसेस ऑफ द beer and iodine. It is again from the research papers of P.K. Das, but the experiment is also from, but it is fluorescence. This time evolution of this reaction was followed by detecting the product of, because here this is the formation and of course bond breaking is also there. So bond breaking is also there and formation is also bond making and bond breaking process. So that time we will not measure the absorption, we will measure the fluorescence. The technique will be that time I will call it time resolve. If you in our DST Pulse lab, why it is called, because there is also we have purchased two lasers, so we excite it and you talk to your research scholars of Dr. Manmohan Satnami, you will find वो कैसे उसको फ्लोरेसेंस को मेजर करते हैं. डीके, टाइम डीके, और ग्राफ भी आप देखेंगे एकदम नीचे आ जाता है. सो दिस इज वन एग्जाम्पल एंड द कॉम्प्लेक्स लास्ट फॉर द 50 पिकोसेकंड. देयर इज नो ऑप्शन, सो वी नीड सम, इतना ही लेजर लगेगा, इतना फास्ट आप उसको फ्रैक्शन ऑफ सेकेंड में इसको कैलकुलेट करना है. देयरफॉर इट इज कॉल्ड द फेम्टोसेकंड और पिकोसेकंड लाइक. एंड अगेन इट इज ऑल्सो पीके द सेम थिंग by your normal again, and you can see this old transition state theory करते हो ना आप. ये एक transition, कोई reaction coordinate and everything is energy and potential energy, everything is there, same thing, but only difference is that real time observation and very very fast reactions. और आपको अभी हम जब इसके बाद हम आपको barrier less chemical reaction, you will be surprised that most of the ultrafast technique and very fast techniques, their energy of activation is negative energy of activation. So there is no barrier. So that is called the barrier-less chemical reactions. Fast, वो आपके कोर्स में है. And then we will study that Bakchi's theory, Hoffman and Argman theory. And last year, Hoffman awarded Nobel Prize in Physics. And वो some biological reactions other things. So अब कब से हम पढ़ाते थे हमको अच्छा लगा रही. हम लोग आपको barrier-less chemical reaction, or one of the scientists was awarded Nobel Prize in Physics last year, 2024. So I was excited that. So you see, similarly you can collect such type of information. I am giving one or two examples. This BR plus one is bond making process, one is the photo fragment. Deliberately I am using two different types of, दो तरह से example मैं आपको दिया. And last example, again, it is this chemical, and I have taken most of the example from chemistry and chemical and engineering news. Same thing is, again, third example is that same thing, ABC or sodium iodide. Again, it is a photo dissociation of the alkali halide. So again, same thing, you see how the pump excites the target molecule. Same language is also same. Into a dissociative state, the probe pulse delayed a variable time, detects, interrogates the photofragment product, and it is being formed the process of separation from C. The probe laser is first tuned to a wavelength, and this resulting photon or photoion signal is recorded at one point, curve intensity with respect to time. So by that method, you can determine these things. The last transparency is that it is a general knowledge question that, sir, what type of laser we must use, which shows 10 to the power minus 12 or 10 to the power minus 15 second. But when I have seen the literature, I have seen that titanium sapphire lasers with advanced dispersion compensation are suitable for particularly short pulse duration between 10 microseconds. And now people are using the dye laser and the development of the semiconductor laser, but during the time of Ahmed Zewail, so they have used this titanium sapphire laser or other things. So let me conclude, young friends. Today I have discussed only the fundamental aspects of the femtochemistry, and I have discussed the contribution of these great scientists, who is the father of femtochemistry, Professor Ahmed Zewail. And in a very simple manner, I have tried to explain what is actually pump probe spectroscopy, and I have tried to differentiate between the transient absorption spectroscopy and time resolved fluorescence spectroscopy. It depends upon the measurement. You are able to measure the absorption or you are able to measure the fluorescence. And it is sufficient for a small question like that. Write short notes on that, like that. And I have also given some of the example studied by the Ahmed Zewail. In my next class, I will try to discuss, first I will see your prospectus, I will discuss the transition state spectroscopy, and then remaining part molecular reaction dynamics and barrierless chemical reaction. Last year also I have prepared some video lectures on that. I think barrierless chemical reaction I have already prepared, because there is a very difficult subject. Not difficult, but it is research oriented, so we don't have any standard test book. So I have taken from the research papers and the literatures. So thank you.